All right, this last one is just a study guide, not a checkup. And let's just go through, again, a little bit more information about triangle congruence and the proofs that we're going to be writing with them. So starting back up here, just a quick review of the postulates. So the main idea is that you sometimes must use other triangle properties and rules to identify the three congruent parts needed for the congruence postulate or theorem. So let's look down here at the 4 shortcuts. Shortcut number 1 is that 2 triangles are congruent if they have 3 pairs of congruent sides. Okay. Postulate number 2 is that 2 triangles are congruent if they have 2 sides, so 2 pairs of congruent sides with a congruent included angle. What does that included angle mean? It means it needs to be in between the 2 sides. That's your SAS. Your ASA is 2 triangles are congruent if they have 2 pairs of congruent angles. With one congruent included side. And finally, AAS is when that side's not in the middle. 2 triangles are congruent if they have 2 pairs of congruent angles and one congruent non-included side. Okay, so these are our 4 postulates. This is what we were supposed to know from Math 1. Now let's go apply these in a couple concepts here. To use any triangle congruence shortcut, you need to know at least 3 pairs of corresponding parts are congruent. So notice that you have like side, 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 that's 3 things. Angle, side, angle, that's 3 things. There always has to be 3 things. Identify that the known parts are congruent is our step 1. Decide how those parts could be used for side, 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 angle, side, angle, or angle, angle, side. Those are our 4 postulates. Use the triangle properties and rules to identify other congruent parts that are needed for the postulate, and then use a theorem to prove that the triangles are congruent. Then we use CPCTC, congruent parts of congruent triangles are congruent, to prove other statements about the triangles, and that's what we're going to demo here. So if these 2 triangles are congruent, triangle BAS and BAC, then, and are right triangles and that they're congruent, prove that AC is equal to AS. And so here comes our actual proof. It's up here on the next page of how we would show this. So stating what was given in the problem, we write as the first statement and its reason would be given. Next, we state that the angles are 90, and that's by the definition of right angles, because we know if they tell us that it's a right angle, we know that the degree is 90. Finally, angle BAS is congruent to angle BAC because they're both right angles. So we're going to say by definition of congruent angles. And that AB is therefore congruent to AB. This is known as the reflexive property. And then triangle BAS is congruent to triangle BAC by the angle side angle postulate. So therefore, we can say that this other side is congruent to this other side by congruent parts of congruent triangles are congruent, CPCTC. This is an example, a brief example of the proofs that we are getting ready to start writing. These are called 2-column proofs. You were supposed to have some experience with this from Math 1, and then COVID hit. So maybe you haven't done proofs like this at all. Maybe you have. But this is what we're going to be working on for the next couple days, is remembering how to write these proofs and all these reasons and justifications in the right-hand side. So on the left go our statements, on the right go our reasons or justifications, and each one goes together, proving whatever they asked us to prove. Did they only ask us to prove that triangles are congruent, or did they ask us to go further and ask something further from that? All right.